Well, hello, everyone. Thank you for coming to yet another episode of Cube by Example Insider. It definitely kind of rolls off the tongue better when you say KBE Insider, but I'm your host. My name is Langdon White. I am a current professor at the University or Boston University, specifically attached to a new unit called the Center for Computing and Data Sciences. And in a fancy new building that is often compared to a Jenga tower, which is kind of entertaining. But I was at Red Hat for a long time. I'm pretty interested in Kubernetes and the ecosystem therein. And the idea behind this show is that we try to interview people who are actually kind of doing the work inside the project. Because what we find with open source is that if you ask if you look at the press releases or you look at the talk to the project managers or product managers, they don't always know what is going to get delivered because you can't control what somebody does on the night and weekends that they might find more interesting. So that's a little bit about me and the show. And my co-host for today is Savitha, and she can introduce herself.
Sure. Thank you, Langdon. Hi, everyone. My name is Savitha Raghunathan, and it's my honor to be here. I have been a guest of the show a couple of times, and then I have the opportunity right now to co-host the rotating bench. And in my day job, I am a software engineer at Red Hat, and I'm focusing on application modernization. That is, like in simple layman terms, migrating apps to Kubernetes and adopting the cloud native technologies. And I'm also a conveyor maintainer and contributor to Kubernetes. So that's all about me. And I'm going to now pass it on to Andrew.
Awesome. Hello, everyone. My name's Andrew Stoycos. I'm a senior software engineer in the Red Hat's office of the CTO. My passion is kind of everything open source. I work in Kubernetes as a maintainer of the SIG network policy subgroup to SIG network, and we work on new network policy related APIs. Additionally, I've really been interested in the intersection of eBPF and Kubernetes, and that's accumulated in one of my other main projects called BPFD, which we'll talk a little bit about today, I'm sure. And yeah, super excited to get going today.
Cool. And how about Robbie? We'll go in alphabetical order by first name.
Hey everyone, I'm Robbie Cochran. I'm a manager lead of the advanced cluster security team that works on runtime collection for securing OpenShift and Kubernetes using eBPF. So eBPF allows us to basically tap into the kernel, figure out what's going on, and then we correlate that data back up with Kubernetes primitives. I joined Red Hat after working at a startup called StackRox, and that project was then open sourced. So StackRox is now an open source project. And yeah, excited to talk about eBPF today.
Cool. All right, Zane, how about you?
Hey, yeah, I'm Zane, and I was the co-founder and CEO of Pixie Labs, which got acquired by New Relic, where it's the GM and GVP. I'm currently an adjunct faculty member at Stanford, and also one of the main contributors and maintainers of the Pixie open source project, which is part of the CNCF.
Cool. And so one of the first things I like to ask is kind of like, what brought you to kind of the open source world in the first place? I particularly enjoy scratch your own inch stories. Whoever wants to kind of go first, what do you think?
I can go.
All right.
I had somewhat of a traditional path. I was actually studying biomedical engineering, super passionate about medical device design in undergrad, and then decided to change it up for computer engineering in grad school at Boston University. Shout out to Langdon. And one course in particular, Introduction to Cloud Computing, kind of enter open source, enter cloud computing, and started working on Keylime, which is another big CNCF project around security and attestation. Started working on that, and here we are a few years later. Yeah.
Nice. How about you, Zane? What brought you into kind of the open source world?
Yeah, I had a pretty traditional path because I studied electrical engineering actually, but moved into software, and I've always been tinkering with Linux and stuff on the side. So I was really a huge fan of the open source community. or rather the many different communities that
Yeah,
exist.
right.
And with Pixie, when we decided to open source it, that really like brought me into like the CNCF and Kubernetes communities, and that was, it's great to just see the whole community grow, because I've been involved with it for a few years, and it's been a fun part. It's been fun to be a part of that.
What would you say is the, like, you said you kind of were involved with Pixie, right? Kind of both before and after you open sourced it. What do you feel like the biggest change was between the, the two different worlds, for lack of a better term?
Yeah. So before we were acquired by New Relic, we were not an open source project. We were kind of always a very community forward project. We had a bunch of stuff in the open source, like, here's like our scripts and workflows, but they were all kind of tied to Pixie fundamentally. And I think one of the biggest shifts to us was after we, decided to open source Pixie, our entire team had to change how we worked on the project. And, I think it's like, it's very hard to articulate exactly what it is, because it's like you got to fundamentally change everything you're doing. All our design reviews and stuff, we started having to do them more in public. And at the beginning, it was pretty scary for a lot of us, right? It's like, oh, we're gonna put in like half unfinished work in the public and get other people to look at it. But it's something that took time for people to just get comfortable with. Just doing everything out in the open. It's like, oh, we file an issue out in the open. Does that mean, if we don't finish it, now it's like embarrassment for us inside and embarrassment for us outside? It's just like a very different mindset to embrace. And I think it, honestly, it took everyone on our team a little bit of time to embrace that mindset of just having things out in the open.
Yeah, I think it is a definitely very interesting phenomenon, right? Like before I got involved at Red Hat, I was mostly, kind of a boutique software consultant, right? And, everyone really, really wanted to own their own IP, especially when they were paying, many dollars an hour for us to build it. But now it's kind of like, why would I make a repo private? Like I have to, sometimes it's actually funny. There's a project we're working on where I kind of automatically made it public and then realized, oh, wait, this is privileged. Like this shouldn't be out there. And it's not because the code is privileged, but because basically the project is privileged. And like I had to go, like actually make it private again. It was a very weird experience, but yeah, it definitely changes how you code.
It's also a little bit of a different mindset. Like once you've kind of, crossed over, like you said, it's very difficult to go back and make things private, because your entire like mindset and development philosophies and everything change.
Right. Yeah. It's super weird. Yeah. What about you, Robbie? What brought you into the open source world?
Well, how far back should I go? I think
the beginning is always entertaining.
The beginning, yeah. I mean, probably it was a funny question, because I was thinking about, I was like, well, probably the first time I encountered open source was with Lego Mindstorms, like in high school or something.
Yeah.
Where I was like, these things can be extended and there's these communities doing stuff. And then I think really what it was like asking a question on a forum and getting a response from a random stranger and then having that connection. And that was really cool. And then in grad school, I did a lot of work on in security and using compiler tools. So I did a lot of extensions with the LLVM compiler framework. And that to me just seemed like the type of project that could only emerge through a community where everyone's adding their different architectures and optimizations and trying out different compiler kind of tweaks and things like that. So I thought that was really, really cool. And then really similar story to Zain, working at StackRox, where we were closed source, but I don't think anyone working on a software project can't be utilizing open source tools and like pulling in libraries and things. And so we were ready to give back, but like you're saying, it's kind of a whole mindset shift. So when we got acquired by Red Hat and were able to open source everything, it was an interesting challenge, thinking through not only like IP stuff, like not IP, but like customer protections and things like that. That was the boring side of it, but the mindset shift, doing things out in the open, and then also seeing how difficult it is to even build a community around a project. That requires its own effort and time, and prioritization changes, like open source issues versus customer issues and things like that. Just the working model has been really interesting to see.
That's interesting. All right, so kind of moving on to what we're really here to talk about. So eBPF, let's kind of say, okay, so first up, can you describe eBPF kind of in terms of maybe not so much what it technically is as much as like what do you feel like it brings to the table? Like why is it interesting, especially in Kubernetes? If y'all have thoughts on that. It's hard when we have three guests, but otherwise I have to call on people, which is always awkward. All right, who's got an idea?
Let's think about it. So eBPF is a pretty powerful, very sharp knife. I like to think of it, right? Like before, contributors had to, write a kernel module and, get that approved and update and maintain a kernel module. And now you can do a lot of the same functionality with an eBPF program, which is basically just a program that gets injected into the kernel. We make sure it's not going to totally break and crash our kernel with the verifier, and then it allows you to do really low level, really fast things, kind of nested deep within the kernel. And I think as it pertains to Kubernetes, like a lot of it's still really unexplored, right? Like it's obviously this amazing knife. It can be used to build a lot of really cool things, such as Pixie. Observability is one of the major use cases. It allows you to do super performant observability, but putting it in Kubernetes, that's a whole nother story. Right? You're no longer thinking about a single node, which is what eBPF is designed for. It was designed in the context of a single node. Now you're starting to think about clusters. And we can talk more about it. I'll let someone else talk. But I think that problem is the most interesting problem. Like eBPF in itself is really complex and interesting, but then also deploying it to Kubernetes in a smart way is really complex and interesting.
Right. How do you balance the, the single node focus versus like a cluster focus kind of idea? Yeah, that makes a lot of sense.
A tale as old as time, yeah, right? I mean, that's
right.
why Kubernetes came about. So,
yeah.
I think one point to add, though, one of the cool things about running eBPF on Kubernetes is, unlike kernel modules, which would be very, very difficult to install on your entire cluster, it is relatively easy, although it comes with its own challenges, to deploy eBPF programs across your entire cluster. So, in some ways you can think about, I'm installing this new kernel module across my entire cluster to do a bunch of functionality without having some of the pitfalls of having a kernel module or the trouble of doing it.
Mm-hmm. Mm-hmm. And I mean the
different pitfalls, but
a lot more dangers, a lot more foot guns, I think, a lot less safeties.
One way that go ahead.
I was going to ask Robbie, you looked like you had a comment to make.
I was going to kind of mention, I think the power of eBPF and Kubernetes also comes from the fact that, like, okay, why do we care about getting data from the kernel? Mm-hmm. And one reason is that it's kind of the common layer shared by all these different types of applications that can be run in a Kubernetes cluster, right? You have different programming languages and different frameworks. But if you're looking for either security data or observability data, of course you can evaluate things in user space, but kernel space gives us some kind of framework static places to attach and get data that's consistent across different application stacks. So that also becomes really useful when you want to have complete coverage for security or observability, or for implementing networking stacks and all the other cool things you can do with eBPF. But that's something that I think about is it's like the kind of lowest common denominator for all these different like things running in your cluster, and that's a good place to tap in and get data at the kernel level. But then you have all these pitfalls as Zane was mentioning about getting kernel modules running. If they crash, at least with eBPF, maybe you get a soft lockup in the worst case, but you're not crashing super hard. But yeah, you have a lot of safety guarantees that are really make it feel more like you're running JavaScript in a browser versus machine code on the processor.
In a kernel module, yeah.
And you're not having to re-roll out your base images every time you want to change something, which is a nightmare, right?
Exactly. Yeah.
Yeah, because kind of just to kind of go back to your opening point, right? Because kind of at the end of the day, everything's a kernel call, right? And so you have that consistency, right, for the for what's happening across your environment, whatever that means. That's it's interesting from an observability perspective. I also think some of the other use cases are really interesting as well. Kind of auditing or error manipulation or kind of those kinds of things are also really interesting, where you can kind of have it's for like a heartbeat, we actually talked about it a lot in the tech world of aspect programming, right? Is you can kind of have an aspect component that is like shared across your environment without having everybody and their brother having to write their own individual versions. So do any of you have any experience with actual BPF, like pre eBPF? I'm just out of curiosity. Like, did you come from there, or did you say, was it more like, hey, there's this eBPF thing, this might be useful to solve some problems I'm having?
No.
Okay.
Never touch the Berkeley packet filter. Yeah, just the Berkeley packet filter.
Yeah, I was just curious. I don't know that I ever actually have like done anything with it, but I know it exists, kind of thing. But I don't think I've ever actually worked on a project. But
I believe if you've used TCP dump before, I believe you're using.
Oh,
BPF.
that's true. Yeah.
So
Wireshark might use it underneath too, right?
Yeah.
So we can claim the fame, right? Whether we actually know what Wireshark was doing or not. But yeah, exactly. Cool. So okay, so now in your kind of individual domains, you're using eBPF for it seems similar purposes, but not necessarily the same. So what is it that you think you're kind of most waiting for in the in that space? I hesitate to say like product or whatever, but like in that concept or space or whatever, that you really think is either going to enable the stuff that you do to be so much better, or is going to allow you to do something new or something like that. How do you feel about that?
I think one of the things that we really nice to have is much more fine-grained security controls around BPF, because right now you can use like seccomp BPF or something, and basically it's like, here you get access to everything, and that kind of from when you're talking to like customers or something, and they're like, oh, I want to lock down certain functionality. It's like, well, please trust us to make sure that they'll never execute bad things in your machines. It's just generally not a good security posture.
Well, they gave us cat BPF, right? Like, isn't that good enough? I don't know.
I'm gonna give you a hard time on that one. Okay, so can you elaborate on that? What did cat BPF do for you or against you? Or
I mean, in my opinion, right? Like original eBPF was like a super rootful application, and in my opinion, it still is. But the kernel kind of tried to break some of these privileges, the ability to load programs, to create maps, et cetera, BPF maps and BPF programs under this bubble of cat BPF. And there's been a couple attempts over the years of like even adding unprivileged BPF to the kernel, trying to add more security controls, and nothing's really stuck. And so just like Zane, like us and Octo are really interested in the security aspect. Like we have customers and users who want to be able to have fine-grained security controls over their BPF, meaning allow certain customers to create certain types of BPF programs, allow certain customers to attach to certain hooks and others not, right? And rather than relying on the kernel to get stuff done, we've started to kind of tackle this in user space with BPFD. And that's kind of where we're going, because although BPF is awesome, the BPF subsystem, moves at a kernel pace. And so we're trying to move a little bit faster, especially in regards to Kubernetes. So bringing, Kubernetes native concepts such as RBAC to BPF.
Can you actually elaborate on that a little bit more? What is it that like, or how are you able to do that in a sense, right? This is a common problem with kind of the kernel module development as well, is how do you do how do you move at a faster pace, right, than the kernel, without the privilege of being kind of inside the kernel?
Well, you can never be like it's more of a deployment problem and a per distro problem, right? So like with BPFD, our whole mindset is that we're going to be an integral piece of a Kubernetes cluster. So then if you're a cluster admin, you know that if someone wants to come and load BPF, you tell them do it via BPFD. Obviously, if you're privileged, you can do it without BPFD. But if you kind of, deploy right and win over cluster admins, like at the end of the day, you do everything through a central daemon, and that daemon can control security and privileges. And like today, you can create an XDP program YAML object, right? And apply standard Kubernetes RBAC to it. So that's kind of the path we're going down for now. And as the kernel kind of develop new security built-in features, we can take more out of BPFD and just kind of use kernel tools that are provided as we go down the road. But we see
that was actually kind of my next question is like the idea is that you kind of are able to model everything you want to build in BPFD, but then, kind of long term BPFD should just go away because it's all been kind of integrated into actual, for lack of a better term, eBPF, or
the security portion. The security portion. I think that's one part of it. The other part is more of the management and loading of BPF programs, right? Like there's so many different angles. There's observability, which we've touched on. There's actually just getting a dang BPF program deployed across your Kubernetes cluster. It's not trivial, right? Like it comes with some privileged daemon sets. Every application has to manage pinpoints of programs, map pinpoints, link pins, et cetera, et cetera. BPFD tries to simplify all that and just let an application worry about interacting with its BPF program and not have to think about the management.
I gotcha. Savitha, did you have a question back?
Yeah, sure. So from what we have established that eBPF is like a Swift knife, right? It can do multiple things, and it's amazing, and it's powerful. But a tool is really powerful and useful when you know how to use it, right? So what is the learning curve of this technology is like, and where do you get started? Like I'm I'm interested in it, and I go to every KubeCon and I'm like, I have 10 new things to learn, and eBPF is the top of my thing, like next to Wasm, which I've never gotten into it soon. But I want to do eBPF because I really like security, and that is one of the things that ties it together. And I used to be a platform engineer. Like so many things come together. And what is the good place to get started, like for newcomers? And what is the learning curve is like?
All right, let's ask Robbie first.
Yeah, I think the learning curve is can be steep, and that's because you essentially can think of eBPF like a debugger where you're attaching to things within the kernel, and then you're triggering events and then running the program based on that event. And so what data you're attaching to, depending on what data it is, that can change things. So I think there are a lot of projects that abstract out some of these like nuances and that make it feel like there's a steep learning curve where it doesn't actually have to be hard to use eBPF. kubectl trace, which is using like some of the BPF trace and BCC tools, allow you to run a eBPF program in a Kubernetes cluster, and really just playing with it is that type of like tool. I think is the best way to get started, where you run a pod, run Nginx, see it's making connections, and then observe that in a tracing program. And that should run on any Kubernetes cluster. You don't have to worry about things getting set up and that sort of thing. So probably the best place to get started is to use the tools, because there's a lot of utility in the tools just for normal Kubernetes development. And then you can start to say like, hey, I wish this had another column of data, or in extending from that perspective. Actually just kind of starting a Kubernetes project from scratch, I think requires almost understanding where the problems are in other areas of the ecosystem. And it's not as easy to do that because it is like, it's not like a new application playground that has things you want to build things in. It's like you really have to have a kind of a targeted use case. But yeah, the kubectl trace is a good place to start.
Cool. What about you, Zane? Do you have more to add? Are you 100% in agreement? Or
yeah, I also think sometimes getting started even outside of Kubernetes could be a good option. It's just easier to do things on a single node and play around with things. And I really like the BPF trace project because that abstracts away a lot of the stuff, but still gives you enough of the details that you're learning, and can then move on to more detailed things over time.
Yeah, BPF trace plus one to that. I think trying to go straight to Kubernetes plus eBPF is a big curve. Like trying to understand the basics of BPF with BPF trace, and there's a ton of examples out there. If you go to ebpf.io, there's a really bunch of great resources there. But that's a good way to get started. Also, Liz Rice wrote a book on eBPF that I still reference today. Like it's really great. And if you want to get deeper, fork and pull down the Linux kernel and start reading, because that's where a lot of the ground up to date stuff is going on, obviously.
I just threw the link in the chat. I wanted to also kind of circle back around a little bit. So I think we mostly heard from Andrew about kind of what you're foreseeing in the future. Zain, what about you? What do you think is the thing that is going to be most interesting for kind of your perspective on eBPF, kind of coming forward? Or also, kind of like, or okay, so if you feel like observability has at least moved a lot, right? What's the next thing that you think would be really interesting to tackle with eBPF?
Yeah, I mean, I think there's already a bunch of work on this, but there are a lot of security use cases for eBPF. I think as Andrew was mentioning earlier, eBPF kind of works at this kernel API layer, so you can essentially see everything on the machine, and that has a lot of benefits versus like trying to install, application-specific agents or code that does monitoring, because this way you can guarantee you're looking at everything. There's some challenges with doing security with eBPF, mostly that eBPF, especially if you start pushing events off in the user space, can be lossy. You want to make sure you get full coverage with things like security. And there are a bunch of security projects coming up, but I think it's definitely going to be an area where, you're trying to monitor for loss of, identifiable information. Like, are you accidentally sending over PII data to some API you're not supposed to? Are you, sending over unencrypted data? Like all of those things could be automatically audited things using eBPF. Interesting.
Yeah. Yeah, we one of the systems I worked on, it was basically for lack of a better term, it was like a pension system. But it had these interesting features where certain users could perform one kind of operation, but if they could perform that kind of operation, they couldn't perform another. So, for example, if they could issue a check, they couldn't change an address. Right. So they couldn't change an address themselves. But I kind of wonder if kind of in the same vein, especially when you're talking about PII, are there places where we could interject auditing such that you can kind of see where those operations are coming from, and kind of say, hey, you tried to, you changed the address and then you issued a check. Oh, and by the way, the changed address is for your house. And so even looking at like series of interactions being kind of what you're auditing, and getting back to compliance, you see this a lot in kind of the stock trading world as well. But yeah, that's I would very much like to see where that goes as well. So kind of going back to Robbie, did you have kind of what's your feeling? What's the next interesting thing in the horizon for you?
I think the eBPF tool world and the community has matured a lot. And so I think a lot of the things I'm looking forward are probably like incremental, small little improvements and polish. So that's one and that's really important because that brings people in, that makes it easier to onboard. And then it also makes it easier to maintain because we're building these projects and then customers are starting to use them and people are using them in large production environments. And then it's like, how do we, BPFD is solving some of these problems of what happens when you have a lot of eBPF programs all attached to the same hook. Well, if they're all outputting the same data, maybe we could have a single tool that emits process data for security tooling or some network observability that can be shared. So I think there's probably some consolidation that could happen with all of these utilities. The other thing that maybe is it's more kind of recent news with eBPF is the core technologies, which stands for compile once, run everywhere, which is really, it's interesting because it's a challenge that occurs if you imagine your eBPF program is attaching at the system call level. system calls are super stable. They don't change from kernel version to kernel version. But if you think of the structs inside the kernel, the task truck or things like that, those fields get moved around, or there's optimizations or something added. So the structs are changing within the kernel within each build. And if you want to attach to those points, you usually need to have the kernel headers to know the right offset for your program. And what core technologies do is allow you to figure out those offsets at runtime. And it's a nice set of technologies that all come together, mostly in the user space, where the compiler that emits the eBPF program, which is a bytecode program, just doesn't resolve all the offsets. It says, okay, I'm going to ask you to look up this field struct later when you're actually running the program. The reason I kind of am mentioning these things is because this has been a huge benefit for us, because we've wanted to support, we started with a kernel module and then migrated to eBPF and are now migrating to core BPF. And in order to make all this work, and it's the same way that the Falco project works, we pre-build the eBPF programs. So for any kernel that we support, we have to have a kind of a backend job that pre-builds the eBPF programs so they just work in the environment. And core allows us to get rid of all that infrastructure and just have a program that works. It's kind of a universal program. So maybe, for someone that's just getting into eBPF, that doesn't sound that interesting, but it solves a huge problem for us to support people that haven't upgraded yet. Because, we've been talking about, eBPF, the next steps of eBPF. Some of the cool things are the tools that let you bring the technologies back to customers that haven't upgraded.
Right. Making it less clunky, basically,
Yeah, exactly.
Yeah, I definitely agree. Huge advantage, but often does not get recognized as such. But when you there's a big difference when it's straightforward enough that it's consumable by whatever kind of just a general enterprise, general organization, and it doesn't have to be the top tier FANGs or the banks or whatever. I think it really does. When you democratize it, right, it really does make a big difference to not only its adoption, but then also you now have so many more people who can conceivably contribute, and they might just be contributing with feature requests, right? But it really does make a difference when you kind of get a lot more perspectives on the software. That is I like I said, I think I agree with you in that it usually gets kind of short shrift, but it is often very, very important.
Is it core or core-e? I always see it. It's always spelled CO-RE. Compile once, run everywhere. I always say core-e, but we can
I just think Java and think compile once, debug everywhere. But because I think that was the core promise of Java. But kind of related. So eBPF is actually a very hot buzzwordy kind of thing right now. The other big one is WASM, or WebAssembly. Do you think there's a relationship between the two? Obviously they're both very hot, but like, is there a model in which knowing both or using both actually brings a positive to each other, or are they just completely unrelated and both super popular? If you have any thoughts, especially if you or if you don't know anything about WebAssembly, that's cool too, and I will give you some commentary.
I don't know that much, but I feel like it's solving slightly different problems, right? Like the core-e technology of BPF is almost kind of like some of the WASM-esque principles, right? Like you can compile it on your machine and run it everywhere, right?
Right. Well, that's kind of what I was getting at is, it's kind of like both of them, and this is, I know, is kind of a reserved term in the Kubernetes land, but both of them kind of model sidecar kind of mechanisms, right? Or aspect-oriented development, or there's a lot of different names of it over the years, and they bring a lot of the same kind of feature set, but potentially in different like layers in the stack, or different, from different orientations, for lack of a better term. And I was just kind of curious if you think that there's any, like I said, is there a correlation between the two, or could there be a future correlation, because they do a lot of very similar things but in very different places. But it seems really hard to have to learn both, and so some sort of, conflation at some point would be interesting. But
I mean, I think the one interesting area that it could, that you could see them work together is if you have like WASM programs or something doing policy enforcement at the user space level. for events that are being generated from eBPF. That way, someone could write like a custom program that could still run inside of a sandbox and, effectively make sure you don't damage the rest of the machine or whatever you're doing while still doing the policy enforcement. That's more complicated than just like YAML files or something like that.
Yeah. Interesting.
Yeah, I mean, we have a similar concept to this, like in Pixie. We don't do any policy enforcement, but we allow a lot of instrumentation using Pixel scripts, which is basically Python. And, in that case, people write Python, but we actually effectively run that in the sandbox. We don't actually have a Python interpreter. And it's a very similar concept, right? But it kind of predates the popularity of WASM running on things. If we had that, we might have considered putting like a WASM increment instead to do a lot of this work.
Yeah, and that's a little bit what I was getting at. Yeah, sorry, Robbie.
Yeah, I thought you were going to, Zane, say that it'd be interesting to run the policy within the kernel. If you could run some WASM within the kernel for like a performance optimization.
Right. I mean, that could be another option because, one of the things about BPF is, a lot of people see like C programs being run and it kind of gives you this illusion that it's, hey, any C program works, but BPF program is much, much, much more restricted, right? I mean, it basically can't be like a Turing complete program because it has to guarantee termination within some number of instructions based on your kernel version. And, that causes all sorts of complications. And even writing loops and stuff in BPF can be very challenging for anything but the most trivial loops.
Pragma unwrap. What is it? Pragma unroll.
Pragma unroll. Yeah. So the loop doesn't terminate, right? Like the problem is that in eBPF, what happens is that the code gets compiled into machine code and executed, and the kernel has to guarantee that machine code is going to finish executing. Otherwise, you will probably hang the kernel. And you can't really guarantee solving like the halting problem. You can't really guarantee that this program is going to stop executing unless you can guarantee that the program is not Turing complete effectively. So it's very, very, very restrictive in what you can do, even though it looks like you're just typing in a bunch of C code.
Right.
So we talked about kernel and a lot of we don't have to code or write kernel modules directly and take advantage of eBPF and do awesome things. And when I think about kernel, I think about Linux, right? Does eBPF work on Windows? Do we have support for Windows? Because Kubernetes has started supporting Windows and whatnot. So, and there are a lot of students and developers still use Windows machine. And if they want to try it out, I know there is always you can put a VM and you can do things in there, but is there a plan for a native support for Windows? Oh.
Yeah, so I think there's I think Langdon just posted there is some BPF for Windows available, or Andrew posted. Sorry, there's a BPF for Windows, but I think one of the challenges with any of those things is that when you write BPF programs, they're so tied to kernel symbols. Like I can say for Pixie, when we're developing the BPF programs, we were just here's the kernel source code. What do we tap into? Right. And it's very, very difficult when, there's so-called BPF support, but not necessarily any of the same APIs available.
Mm-hmm.
Although I thought,
Andrew, if you have more thoughts on it.
I thought in the old days, I thought BPF did get ported to Windows a billion years ago. For that kind of same problem, especially in the days when we were looking for much higher levels of particularly network interop between Windows and Linux land, or really Unix land in those days. But
I actually think you're right. There is a packet filter thing for Windows for BPF, but I think one of the things is that eBPF has kind of outgrown its original.
Oh yeah, totally. Right, but at least the underpinnings are there. That's kind of, I guess, what I was getting at. Yeah.
Yeah, I mean, I think fundamentally, I'm trying to remember the name is, but Windows has something pretty similar to eBPF that they have natively. But again, I think the main issues are, it's how do you make your programs portable if the APIs aren't the same on the other side?
Right. Andrew, are you familiar with this GitHub project, or was it more you found it with Google?
I have known about it. I am not familiar with it. I am no Windows whiz at all. But I know, like, in Kubernetes, like Windows support, I have some friends working on Windows support for a lot of different things. So it's definitely something that I'm sure people are talking about, right?
Yeah. Well, one of the reasons that I think it's funny, like kernel level stuff crossing over into Windows is often easier because way back in the day, in like the early 2000s, NT was not very prevalent, right, in the data center, and in order to make it more prevalent, it needed to interoperate with Unix and Linux much better, right? And and while a lot of that kind of died off, there's actually like kernel headers that somehow actually get into the Windows kernel but look like Linux kernel headers, and that's how things like WSL work, and actually on the Windows phone, how like Android apps would run on a Windows phone. So at the lowest levels of kind of Windows, there's actually more sometimes easier integration points because of this long-standing legacy of NT working with Unix. So that's why it wouldn't entirely surprise me that we could see that going forward, and that being something that's interesting to Microsoft, right? Is making it so you could have whatever, like your observability actually work across a Windows node and a Linux node or whatever.
Yeah, I think as Zane was saying, the challenges of, I haven't done any eBPF on Windows, but I'm sure that the eBPF program would need to be modified to run on Windows.
Right.
Just like I can't write an eBPF program for an x86 kernel and have it run on a ARM kernel. I've never tried that, but I'm pretty sure that's not going to work. But the user space can still use the same interface to interact with the program. And so I think that's the advantage with using eBPF on Windows or that sort of thing. It's like you could have a more common interface with the kernel or with the Windows kernel.
Purely in the like, because you have to solve the problem already with x86 versus ARM, for example. What's the difference, right?
Yeah, in the beginning of this year, we actually ported Pixie to work on ARM in addition to x86. And part of the challenge there, Robbie was pointing out, is that you can't just like directly translate it, because a lot of the struct offsets and stuff that they use, because part of the problem with eBPF, right, is that as long as you're monitoring like the system call API, everything is great. But as soon as you start poking into like kernel structs, you start effectively breaking your contract with the kernel that the API layer remains unchanged. And now you're starting to poke into some of the internals of the kernel. And those are definitely not going to match with Windows unless there's some facade layer that gives you the exact struct offsets. And as Robbie was saying, they're not even the same between x86 and ARM usually, because there's like additional fields that are added that move the offsets around.
Mm-hmm.
So that's one of the challenges that we had to deal with as we ported Pixie to ARM in addition to x86.
So Zane, did you have to, like, when you went under that transition, like, are you maintaining two different programs for some of your core functionality, or are you just maintaining different header files, like, with the correct offsets?
There are different header files, and then we added like a facade for some of the things that we needed, like task structs and stuff that are slightly different. Cool. Okay. And then and one of the things we did is that we got all of the stuff to run on QEMU, so we could run all the tests across different processors. So that was pretty nice. Another open source project help out there.
Cool.
Yeah,
That's awesome.
Some architectures even use different system call setups.
Yeah.
Like for I believe it was for IBM Z, they use their kernels use some old system calls that haven't been migrated to x86 64. So it's like goes back to 32-bit x86, like the socket call, system call, which multiplexes all of the networking system calls. And so when you're migrating to different architectures or platforms, a lot of interesting stuff can come out of the woodwork, or like because you're making assumptions about where the data is expected to be on a particular platform.
Right. So yeah, I think the biggest difference for us that was annoying over there is that the call order for functions and the way arguments are passed is different.
Mm-hmm.
So when you're trying to like intercept function calls, you're like, is this ARM or x86? Because they're going to pass arguments in different ways.
Yeah, because I assume you're using a lot of K probes and trace points, where like trace points are a little more stable. K probes are kind of a nightmare.
Yeah. And making all this even more interesting is people are starting to use mixed topology Kubernetes clusters. So running some, having some ARM nodes for your monitoring, and then x86 for your other workloads and different sorts of things like that. So that makes it even more fun to support these mixed topology clusters.
Yeah, I mean, what's really cool over there is like the ability to deploy multi-arch images, because that's what we do with Pixie. So like for all of our components, it can run either on ARM or x86.
Cool.
And we basically use multi-arch images to switch between them.
Do those just have a layer that's like different binaries, one for x86, one for ARM? Like
when you basically pull the Docker manifest, it basically points to other images.
Okay, cool.
It's kind of like another layer of indirection.
Cool.
Yeah, so I was going to kind of ask that. Is it like, to the best of my knowledge, is there this doesn't really exist, but do you foresee an automated deployment tool chain, something or another, for these eBPF functions into clusters that are multi-arch, or like in Robbie's case in particular, right? Multi-cluster, kind of spread out all over the place, because there's no particularly good way to distribute that.
Well, we've started BPFD packages, BPF programs, and OCI container images. So following with what Wasm does, Wasm has written their own OCI distribution spec to distribute their Wasm binaries. We've kind of piggybacked off that, written our own in BPFD to distribute BPF programs. So like one day, multi-arch, why not?
Yeah, I mean, there is multi-arch deployment with OCI. That's what I was basically saying, is that there's basically a manifest file that tells you, oh, is this an ARM? Pull the ARM binaries. If it's x86, pull the x86 binaries. Now, if you take a look at like the Pixie code, for example, there's actually no difference in the BPF programs between ARM and x86, because there's some if-def in the header that gets compiled.
Yeah.
And the last level of compilation, which converts the BPF code down to, the instruction set, is done on the kernel itself. So it'll by default work.
Right. So you are compiling on the kernel. Like you're not pre-compiling your BPF program state. You're compiling on the fly.
That's right. Pixie still doesn't use core. For various reasons, because we actually generate a bunch of BPF code to intercept different types of applications.
When you say generate, do you mean in real time, or do you mean in deploy time?
Well, Pixie does it in real time. So once it's deployed, if it sees like a new application coming on, it needs to generate a program with like the right offsets and everything that we need.
I gotcha. Cool.
Yeah, so we typically watch for new programs coming on. And if it's like a Go program, we do different things. If it's a program that uses the OpenSSL library, we add some additional trace points for that. So there's a whole bunch of dynamic stuff that happens in the back end.
That's interesting.
Yeah.
So do you have users who are unhappy about then you're shipping basically a compiler, right? So do you have any users unhappy on the security side of things with you compiling on the fly?
I don't think people have been unhappy on the security side, because that doesn't really change anything from the kernel verifier perspective, because the kernel still verifies it and makes sure that you're not going to mess with the kernel. I think the one annoyance is that our images are pretty large, because we basically ship LLVM with it.
Right.
Yeah. And we at BPFD are trying to push people away from that. Obviously, you have a bunch of constraints, but we really focus on core, and it'll be interesting to see how core kind of intersects with your use case, right? How do we make it more portable?
I mean, our goal is to eventually move to something like core, because that'll make a lot of things easier for us.
Yep.
It's just that I think when we started looking at it last time, it was just didn't have the capabilities that we needed back then, but it's obviously an amazing project.
And it'd be a lot of work, right? I mean, it'd be a lot of work. How you deploy, a ton of work. That's kind of the barrier to entry we're running into with BPFD, is like all these applications, their stuff works today, and it'll work with BPFD, but we have to convince users like you that like the benefits of using something in the middle outweighs the cons of having to implement the work. It's kind of cool.
Sorry, I was just looking for a link to Corey here. But
I'm doing the same too on the side. Like if we can just share it out, and I only found a blog post. But yeah, I'll keep looking.
It's built on the kernel BTF, basically, is how the internals of it work. So I like when I think about Corey, I automatically think about BTF. Some low-level docs there.
Yeah, it's kind of more like a part of BPF rather than an independent project per se. Sorry. Yeah, so let's see. I was going to try to finish that up, but then I got distracted. So kind of final thoughts, like we're almost out of time. What do you like, why are you going to stick with BPF? Presuming that you are with eBPF over the next 2 years, like what remains so interesting about this particular kind of technology that would be interesting to others, or not, but you get my idea. Let's start with Robbie.
So I'm excited about like some of the stuff we've been talking about, all these new features, and I didn't even get into the challenges of like what's the overhead of running an eBPF program in your environment. And so it brings all this value, but then how do we find bottlenecks? How do we improve performance? And I think there's a lot of like kind of greenfield for performance tooling for BPF. Like this is running in a different domain. How do I measure the overhead and that sort of thing? So I'm excited about BPF becoming more commonplace and more people understanding it, and all the new features that are coming on as well with enforcement. We didn't even get into LSMs and some of the other interesting things, security things that can be done where you're actually able to embed some small little policy logic into your kernel, and it's super performant, and you also get good feedback and insights. So yeah, I think there's just a lot of stuff going on in the community, and excited about all of it.
Gotcha. Cool. How about you, Andrew? Sorry.
No, it's totally fine. For me, it's just a really, really exciting technology. I started as a Kubernetes developer. I did everything in Go, That's how I learned to program. I love Kubernetes. I love the ecosystem. But you get to a certain level where you can't do everything in Go, and you can't do everything at those upper layers of the stack. And BPF is so cool because I don't want to be a kernel developer, but I can learn a lot about the kernel. I can now interact with the kernel. I can basically write programs that are running in the kernel and get some of the same functionality without having to sit there and iterate on kernel patches, which is super exciting. Alongside that, I think the community is still super young with eBPF, and it's a really exciting technology, but there's so much yet to be discovered and explored. So it'll be really, really exciting to see how Kubernetes as a community adopts it, and how we can, take a bunch of Go developers who are really good at Go and say, okay, let's start thinking about BPF. And we do a lot of Rust, but we didn't talk about that either at all. But Rust, we can write eBPF in Rust, which is super fun. Check out Aya.
You can write kernel modules in Rust now. So
yeah, I love Rust. It's awesome.
How about you, Zane? What do you think?
Yeah, I think, before we were talking about how everything in eBPF moves at kernel speed, right? I think one of the cool things about eBPF is it allows a layer of it to basically move a lot faster than kernel speed. This is kind of just building off of what Andrew was saying is now you can write a program that basically, does a lot of the functionality a kernel module can do. Obviously can't do everything kernel module can do, but you can do this and iterate a lot faster because, in some ways the risk of breaking the kernel are much, much lower because, well, the verifier should guarantee that. I'm not saying that there aren't things that you can do that will completely break things, but it is harder than with a kernel module where you could just cause a kernel panic pretty easily. So it's pretty exciting from just like innovating a lot of the kernel functionality by working on this eBPF layer, and I think that is pretty good place to be.
Cool. Yeah, totally. That totally makes sense. Yeah, I think it's really interesting. Like, I've been a long-standing fan of like I said, I keep bringing up like aspect programming, or kind of like having functionality that is kind of available to the entire environment. Is, I think, a really interesting development model. I'm a big fan of event-driven architectures. Which is kind of the cloud-native development world in general. And so I think they don't get enough, because if you go to school and take a computer science class, right, or take a set of them, right, they don't really talk about kind of all these things that are kind of on the side of all of writing your Python script or writing your website, right, that are really quite interesting and really important to making sure your operation, your application really can perform at the levels it needs to perform at, especially when they get complex, right? So let me just throw the book that somebody mentioned earlier, but I don't remember who brought it up in the first place, but Savitha dug up the details on it. Thank you, Savitha. And let me make sure I typed your name correctly, but I was just going to throw that in the chat so people can check it out if they want to. But with that, let's say thanks so much for coming. We really appreciate your time. Unless there were any other final thoughts that you wanted to add. Cool. All right, Savitha, thank you for co-hosting yet again, and hopefully we'll see you all sometime soon in the future. Maybe if you're at KubeCon in Chicago, hopefully I'll be driving around interviewing people again. And we're not sure what kind of car it's going to be, but there's a couple on the table that should be a lot of fun. So we're excited to be planning that out. So maybe we'll see y'all in Chicago, maybe Paris, but or next time on the show. Bye all.
Awesome. Bye.
Bye,
Thanks,
everyone.
everybody.
Bye.
Thank you.